Hello everyone, my name is Pen and you're welcome to my C programming language tutorial. Today we are going to learn error handling in C programming language. Relative to my previous video where we write a simple chat application in C programming language, I was explaining about error handling and I said that to make that video short or not to be too long, that I have to do the error teaching about error handling or error checking in C programming language in a separate video. So that is what we are going to be doing today. Okay, a brief talk about error handling. Okay, when you are doing low level programming, okay, and the program you are writing is going to be a productive one, okay, a program that will be used, okay, that will involve in our society, that company or vendor is going to be using for their productivity and all that. Okay, in such writing such code, you must do what we call error checking. Okay, because most times we write functions ourselves, which I have done, and most times also, or almost all times, we use function written by world-class programmers or world-class hackers all over different countries. Okay, and these functions, when you look at the man page of the Linux operating system, we have every functions have different sections, and it also has its ways it do its error checking. Okay. So that error checking number has to do with -1. If you are using any function and you want to do, maybe you want to check for errors, and if your program encounter maybe -1, that means error is set. Now the error number relative to that function you use will be set to the error num variable, character of variable, number of variable, which is an integer. So, and when you use a different function, maybe error or string error, you can print out the strings or what that error actually is. So basically today we are going to see those errors. They are about 133 or 135 errors thereabout, though, but I know it's either 133 or 135. Okay, so program we're going to be writing today is to print those errors, and we scroll through or go through those errors one after the other, seeing what each and of those errors actually means and what they are, so that if you are writing a real world productive programs, you also understand what the error is doing, and the error, why you're getting this error, and how you need to fix this error. Okay, so without further wasting of time, let's dive into the purpose of today's video. So I'll press Ctrl L to clear the screen, Ctrl U to remove the welcome to Pen-C programming tutorial. The link you are seeing by the right hand side is my link to my YouTube channel. Okay, you just go to https stands for Hypertext Transfer Protocol Secure. Okay, youtube.com/at_hackpace. That is my YouTube channel name. Okay, and even the TikTok also is Hackpace. Okay, so you guys do well to subscribe and comment, and also like my video. Turn on the notification bell so that whenever I drop a new video, you as well receive it from your end. Okay, without further wasting of time, let's continue. So I press Ctrl E to clear off this string so that we can continue. Okay, in Linux there are so many different commands that you can use. There is a command called mk, which I have been using in all my videos. Why? Because I want to always create a new environment where we'll do our stuff or the tutorial we're going to be learning. So I use the mkdir to create a separate directory, and I'll call this directory error_check. Okay, and I press enter. That mkdir shows us or creates for us the error check directory. Okay, right now move into the directory by typing cd, which stands for change directory. Where are we changing to the error_checking? If you just type something, you just press tab, it auto completes this for you. Press my enter key. Now you can see I'm inside that directory. All right, I'll clear the screen. If I do ls, you see there is no files at all inside here. Why? Because we have not created any file. There is also a command called tosh. Okay, tosh. I really don't know the reason why they gave this program or this command tosh, because what it does is to create an empty file for us, give permissions to those files, which is 644. The user or the owner of the file have right to read and write, but not execute. The groups have only read permission, and while every other person has read permission as well. If I do something like maybe we create a file with the tosh, and we'll call this file error number, we'll call this check error number checking.c. Now we press enter. This touch will create this file for us. Okay, the file has been created. If I do ls, we see the file. Okay, we can see the permission of the file by doing ls, putting a option that is -l. Okay, press enter. Now you can see the group, the owner of the file have read and write. Every other person have no permission at all. That is because I'm using Tmos, which is my smartphone, to make this video. But if you are using your laptops, desktop, and you're running Ubuntu, Linux Mint, Fedora, Ash, Parrot, Manjaro, any OS, you will see that it will give you permission of 644. Okay, all right. So that is it. Maybe I'll swear do that in a separate video to teach you permissions. Okay, but for now we are doing error checking. So I clear my screen and I do ls. You can see the file has been created with .c extension. The .c you see there tells the CPU that or the kernel itself, okay, that this is a file and this file should be handled or executed as a C programming language. Okay, and any program you're writing, despite the language, has an extension. The extension is what makes the kernel to understand that this language is sitting in Java, or is sitting in PHP, or is written in C, or C++, or Rust, or C#, or Objective-C, or Swift, or even HTML and CSS. Okay, so the extension is what it really matters. If you do not put the extension, the kernel or the CPU will handle that file as a regular file. Okay, and to be sincere, all files have extension. We have .txt, we have .txt, which is a regular file. We have markdown, which is a readme file that has to do with markdown, you giving illustration of what your program is doing. We have different .c, .cpp, we have .java and the rest. Okay, we even have .js, javascript. Also we have .php, okay, .html space .css. These are different extensions. There are thousands of them. If there are thousands language though, but every file has an extension. If you are doing a music, it has .mp3. okay, that is the extension to indicate that this is a music. If you are doing a picture, it has .png. okay, that means it's a picture. Okay, if you are doing video, it will have .jpg, that is a video. Let me make it a little bit smaller so it fits. Okay, Ctrl L, you can see it .jpg or .jpeg. okay, and that is it. So these are different extensions. Okay, this extension matters. So I'm still going to write a program that on mp3 programs, a .jpg for video programs in C language. These are things we're going to be doing. Okay, so all you guys need to do is to follow me in this my YouTube channel, and also subscribe as well so that you receive notification anytime I drop a new video. Okay, enough of this explanation of the extension, so let us dive straight into the purpose of this video. I'll do Ctrl U to clear all this dot extension, and that is it. So the next thing now is I'll give a quick demo explanation of what this error means. Okay, if you are writing a function, maybe a function that can create a file, open a file, read a file, or close a file, that functions is written by world-class programmer. Most times we write functions ourselves, which myself have done, and most times we don't even add error checking. Okay, but real programmers, they add error checking. Okay, if you are using the open system call, for example, the open system, okay, call for example, okay, this open system can always return 0 for success and -1 for error. So if the -1 is indicated, error number is set to the file called ERRNO. So this ERRNO will hold the error number. Okay, the error number can be 1, 2, 3 till 133 or 135. Okay, just depending if the error number actually is 133 or 135. But we're gonna see it today though, because we're going to be writing a program that will print all the error number and give us a string, which is a illustration of what each error number actually means, so that we understand these things very, very well. Okay, so let us see how these things work. So I'll do Ctrl U. If I say error number and I give it a specific number, maybe 1, okay, you see it give us EPERM, which stands for error permitted, which is the error number 1, which simply means operation not permitted. Maybe you are trying to access a directory or trying to perform an operation, and you don't have access to that permission, which you never you never give yourself the permission. Then this error EPREM will be returned back to the actual variable or file descriptor you were using, and the error number is being set to this ERRNO. Okay, so that is what it is. We can as well see maybe 3. We see this one means no such processes. We can say error number maybe 10. This one means error number that no child process is running. We can say error number 100. This one means you see the name ENET down, that is network is down. So when you have a network that is down, this is the error number that you will get. Okay, so we are going to write a program that is going to be printing all this error for us. What about doing error number 0? Now this one won't print anything to the screen, it will just return to the next line. Why? Because 0 is not an error. Okay, 0 simply means success, that we have reached the end of this program or the end of a file. So pressing enter, we just move our cursor to the next line, because this means success. If we do something like echo $sign and question mark, we will see 0. Okay, 1, which simply means the error number we have been checking. But if we write a program that we are returning something, okay, maybe we are returning 0, then it would, if we run this echo $1 $sign question mark, it will give us 0, that we return something. It's because the error number itself we are checking is just a program written for you to see the error number. Okay, so that is it. What if we do error number -1? Then you will see that invalid operator, because this is what actually set the error number for us. So all right guys, let's see how this thing works and print out these errors one after another. So I will do vim use the error.c file, press enter. I'll press I, then I have to include the stdio.h. I close. I also have to include the string.h. all right. I also have to include the error number.h, so that we can have access to this. Let me give it a comment though. Sorry. We can have access to this variable. All right, so that is it for now. So I will just say int main. We are not accepting anything from the into the main parameter. So I will just close this, open this, and return 0. When we use the echo $sign and we say return 0, this is where 0 will be printed as we have reached the end of file. So this simply means and reach the end of program, or end of maybe file, because every program is a file /process. Okay, */ I'm just giving that comment there. Then the next thing here, I will just close this. So we write our program first of all by creating an integer of I that we hold the value of 0, and we should do an iteration loop that we loop till 135 or 133. So the next thing here is we do for loop. Okay, I will say I equals 0. 0 is always indicate success. So we say I, if I is less than 133 first, okay, or let's say 135. If it's up to 135, but if it's not up to, that means it's 133. We'll just come back and fix that. Say semicolon, and we do I++, and we close this. Okay, so I will just enter this, and I will use the printf function. Okay, I will use the printf function to print to the screen. I want to print audio error. So first of all, I will do %d. I'll say I will do %d this, and I'll do arrow sign 3 times like this, and I'll do %x \n double quote comma, and I will pass I. The first there is the iteration itself, and I'll use the string error which we have been using, and I will pass in I into it, and I will close this. So this is a simple illustration of how this program will work. Okay, but this is gonna be fast. Okay, so this program is gonna be fast, like it will print everything in speed. But we'll come back and just run this program and see. We do not put any slow motion there, so it's gonna be fast when it's doing its printing. So press enter. So we made a mistake there. Vim error checking.c. Where am I making a mistake? Okay, yeah, the error number, you can see it. So I'm going to put 2 arrows, so it's supposed to be 1 R, and that is it. So, and we just go and compile again, and gcc error checking -o, and we'll call it error checking, and it compiles. So we have our executable file. Do .error checking, and if I run now, you can see okay, is 133. That is the actual, because the 134 means unknown error, because it ends as 133. I was just like assuming, because I forgot if it is 133 or up to 135. So let us just fix that. So error checking.c, and we just fix only the iteration number. So put this to 134. That means start from 0, right? If I'm not mistaken, it should start from 0 though. Yeah. So /error checking, and yeah, we got it. So if we go to the top, you can see 133 means memory page as hardware error. Okay, that means we are encountering a very sophisticated hardware problem. So all these things are error numbers. 14 simply means bad address. 15 simply means block address required. 16 simply error means okay, let me put a string there. Let me just fix a string, guys. Let me fix a string for this. Say .c. So in the print, we say, I'll just say error number. Okay, so we say error number 1, error num1. That is the error number. Actually, the error no means error number. Okay, or I can just let me just make this more this for you guys, so that you guys don't be confused. So I'll just like say error number. Okay, so that you guys will actually understand. So I will compile this again. It compiles ./error, and this is it. So error number 133 means memory page as hardware problems. You can see different errors. All these things are what we use to write powerful software that runs in your aircraft, your vehicle, whatever. You can see error 58 means an unknown error, which means they have not yet added error for that, or maybe it simply means an unknown error though. Invalid request code, no code, exchange full, that is error 54, error number 54. So error number 51 means level 2 halted. Okay, if you are doing the CSI structure available, that is error 50. Protocol driver not attached, that is error 49, and error 48 simply means link number out of range. If you go, you can see different. You can see circuit type not supported. Okay, 94 error. Maybe when you put a wrong socket that is not IPv4 or IPv6. These are different errors. Okay, these are different errors. You see, it starts from error 0. Error, you see it now. Error 0 simply means success. You see what I'm saying? Error 0 simply means what? Success. So that is what error 0 simply means. So when you encounter error 0, it means success. If I clear the screen and type echo $sign question mark, press enter. Sorry, the echo did not spell it complete. Echo $sign question mark. You can see error number 128. Okay. So let's run our program now. 127. Let's see what it actually means. Say 127 simply means key has expired. 127 error simply means key had expired. Okay, so there is more to this. Errors is something that when you're writing code, that's why you see me in those code I was writing, I was checking error in every bit of functions I'm using. Okay, so that is it about everything that has to do with error. If you want to like shake this error one after the other, just like error 61 simply means no data available. Maybe you don't want to write a program like this that will just prompted error. Maybe you just want to know what error 61 means. Okay, which simply means here no data available. If we clear the screen now and type error number 61, you see it will give us no data available. Sorry, the spelling was incorrect. Error number 61. Now you see no data available. It means ENODATA, no data available. Okay, so what of when we run our program again, let's see the error 133. It simply means error 133 simply means memory page as hardware value. So let us try that. Error number, we are assuming that we do not write any program now, so we say 133 and we'll press enter, and you see, wow, 133 memory page has hardware value error. If you don't have this error, you try to run this code, maybe error 1, maybe like this, to check, and you are getting error number not installed or something like that. You just install that. You can do super user do apt-get install. If you are using WXL in Windows, you do the same thing. It works. You will install what we call more more utils. So if you install these tools, you will have access to this ERRNO. You have access to it. Okay, so it's in case ERRNO is not working, because it's a program written to show you the error one after another once you pass argument to it. If you don't if you run it, you're not getting. If you run this ERRNO is not working, then you have to install this super user apt-get install more utilities. Once you install this, then you will have access to use this error number check. Okay, I hope you guys love this. So that is this is something that one must know, one need to learn, and is something very, 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 very interesting. Okay, another thing I would like to show you guys before we end this video is, you can look, if you look like this, there's what we call object code. Okay, this one is just something I'm just adding to this tutorial. There's what we call object code. You people normally hear about object code. Object code is a code that has been compiled. Okay, it has been compiled to become to have .o extension, which means is now an object code. If I say cat the actual binary like this, now it will give us object code. So these are what we call object code. Okay, this is the object code of this code we run, of this our error checking, which is in green color. Okay, that is object code. But if you want to see it with the actual object .o, you use the dash, you use the GCC, use -c and do error number .c. If you press enter now, okay, it compiles. If you do ls, you see it error number checking.o. You got the object file. This is the object file we use to create library. So if you cut this error number.o, you get those same object code. Are you seeing it? Those same object code. Okay, this object code simply means that your code has not been linked to become a binary form. Okay, to become a binary form. All right, so if you want to link it now, maybe say GCC this same error.o, then you do -o, then you give it, maybe let me give it ERRNO_CH. Then you compile, it compile. Now we have gotten another compilation. You see error number_C. Okay, so this is how these things works. okay, you will be able to see the actual object code and the actual executable code. But this thing we call executable code, yes, is it when you cut it normal, when you cut it, okay, it gives you, when you cut it, it gives you the same object code. You can actually see the binary code, which is what I've done in my previous video, by using the ssd space -b and pass in the actual object code. Now you see, these are the binaries of this code we wrote. You can see everything, 1 and 0, 1s and 0, 1s and 0. The number at the left hand side that end with a column is the memory address, while that is in green, that is at the right hand side ending, is the actual object code and also the actual file of our program. But all these 1s and 0 in the middle is the binary code of our program. Okay, I hope that is understood. All right, so we have done a lot today, and to end everything and wrap it all, if you also want to see the assembly code of your C, because C code is compiled into assembly first before it go to its object code, and from object code to its binary. To do that, you just type the GCC, we get our error.c file, our error checking.c file, and we put at the beginning of this, we put minus uppercase X. Okay, and that means we want this code to give us an assembly.s file. Press enter and we'll do ls. We see the error check underscore .s, which means this is an assembly code. If we cut this, okay, if we cut this with the .s, you will see the actual assembly. Now this is the assembly codes. Okay, this is assembly code in the 8086. Okay, yeah, 8086. So this is the assembly code for 8086. All right, so a lot of all this, so I hope you guys learned a lot today, and we, at least you have basic knowledge of how error works in C programming language. The same thing we did here is same in C++. Okay, you can apply this, you can use the knowledge of this in other languages as well, but in the way you write the program, in the way it's written in that language. But this is for C and C++, but the idea can be ported to every other languages as well. Okay, so my name is Pen, and it's been educational hanging out with you guys. I hope you guys love this. Please make sure you give me a like, make sure you subscribe to my YouTube channel at https://youtube.com/@hackbase. Okay, so this is my YouTube channel. Okay, and make sure you visit this site and watch the video. Or if you're also interested in learning the C programming language, you can DM me on TikTok, or you can contact me on contact on 091 +1 +234 913 216 5565. So that is my WhatsApp number. You can add me up on WhatsApp and link up with me. Okay, so have a nice day, guys. Be blessed, and wishing you a long life, full of happiness, joy. Okay, death is none of you guys' portion. This year will be a year of prosperity. It will be a year of open doors, blessings from east, west, north, and south. I wish you all guys the best, and see you guys tomorrow that I will come live on TikTok. Have a nice day. Bye.